Well, the next collection of problems are all looking at derivatives from a graphical perspective. And so we have this graph with these points A, B, C, D, and E on it. And we're asked, between which two consecutive points is the average rate of change the greatest? Well, the average rate of change is just the slope of the line connecting those 2 points. So between A and B, it's going to look like that. Between B and C, it would look like that. Between C and D, it would look like that. And between, well, and it does say consecutive points, so I'm correct to assume that. Now, which of these lines that I've drawn there between any 2 consecutive points has the greatest slope? Well, the greatest slope would be the most positive slope, and that's going to turn out to be the slope of the line connecting points A and B. And so A and B would be the answer there. So the average rate of change is the slope of the line connecting 2 points. And some of them are positive, and some are negative, and some are more positive than others. So the line connecting A and B would be the average rate of change between those is greater than any others. All right, number 25. Is the average rate of change of the function between A and B greater than or less than the instantaneous rate of change at B? So I'm just going to erase these right now. Well, let's see if I didn't have to do that. If I was to add another graph, another tangent line on there, at B, is the average rate of change, or the slope of the line connecting points A and B, greater than the tangent line at B, which is the instantaneous rate of change? And the answer to that would be yes. Right, the slopes are decreasing as you go up that hill. Hopefully you can see that. And we will go on to the next problem here. And we get, use the graph in 26 below to answer the following questions. Here we go. Determine f prime of A for A is equal to 1, 2, 4, 7. So f prime of 1, we're looking for the slope of the tangent line when x is equal to 1. Well, what's the slope of that line? It's 0. How about at 2? F prime of 2, it's also equal to 0. F prime of 4, well, hopefully you can see there that the slope of that line is positive 1/2. At 7, we have a horizontal tangent, so the slope there is 0. And which is greater, the slope at 5.5 or the slope at 6.5? Slope at 5.5 would be here. Slope at 6.5 would be there. And I think you can see that the slopes are going towards 0 as we move to the right. So the answer here would be f prime of 5.5. Right? We'll go on from that and look at number 27. Write an equation of a tangent line and of the normal line at x equals 3, assuming that f of 3 is 5 and f prime of 3 is 2. Alright, so remember that to write any tangent line, equation of a tangent line, we need a slope. Well, the slope is the derivative at 3. If we want the tangent line at x equals 3, we need the slope at x equals 3, and that's just 2. And the point, the x-coordinate is 3, the y-coordinate we're given is 5, and so it's just as simple as y minus 5 is equal to 2 times x minus 3. And you can multiply that out or not, doesn't really matter as far as I'm concerned. Now, next, we want to write the equation of the normal line. A normal line is a line that is perpendicular to the tangent line at the point of tangency. Normal line. So, normal line is perpendicular to the tangent line at the point of tangency. If I have a graph that looks like this, its tangent line might look something like that at this point of tangency. Then the normal line would become perpendicular to the tangent at that point of tangency. And we know that perpendicular lines have slopes that are inverse and opposite, or opposite reciprocals. And so in this case, the slope of the perpendicular line would be -1/2. If the slope of the tangent line is 2, the slope of the perpendicular line is -1/2, and we can then just put that right in. Y minus 5, the point is still the same, it's still 3, 5. Y minus 5 is equal to -1/2 x minus 3. And again, that can be written out in y equals mx plus b form, but it doesn't have to be. And we'll stop this video at this point.